Okay, let's now discuss orthogonal trajectories, an application of the ordinary differential equation. Okay, an orthogonal trajectory of a given family of curves is a curve that is perpendicular to every curve of the family. Now, okay, if we let f x, y, z equals 0 be a family of curves represented by the differential equation mxy dx plus nxy dy is 0, okay, the corresponding orthogonal trajectory called that gxyk0 is obtained by determining the solution of the differential equation nxy dx minus mxy dy is 0. Now let us see the rationale. Let us see the rationale behind this. Now look, in this differential equation, alright, the slope dy dx, okay, can be computed as negative m over n. While in this differential equation, which is the orthogonal trajectory, uh, okay, the slope dy dx is equal to n over m. Notice that if you multiply this one by this one, okay, alright, that will give you negative 1, and it means that the slope of the orthogonal trajectory and the slope of the original curve here, okay, has the product of the slope negative 1, and therefore they are orthogonal with each other. Now let's have an example. Okay, find the orthogonal trajectories of the family of curves y squared is cx. Now, what is this y squared is cx? Actually, this will be a family of what? A family of horizontal parabolas. There. Okay, there. Okay, it could be what? It could be like that, or it could be like that. Of course, this is your y, and this is your x. Okay. Now, the first step is, okay, form the differential equation m dx plus n dy equals 0 from, okay, from this equation y squared is cx. Now the step is to eliminate the arbitrary constants. So let's start with y squared is cx. We will have to eliminate c and find the equivalent differential equation. So, okay, here, get the derivative of y squared, that's 2y y prime, and then get the derivative of cx is c, and what you do is what? What you do is, okay, you substitute the value of what? The value of c there. So, you get what? You get y squared is 2y y prime x. Then arrange it. Okay, arrange it. You can write it as what? You can write it as 2x y prime minus y squared is 0. Of course, your y prime, okay, your y prime is the same as what? Your y prime here, that's the same as dy dx. Okay, dy dx. So, rewrite it as, okay, multiply both sides by dx and rewrite that as 2xy dy minus y squared dx is 0. Okay, simplify this by dividing both sides by y. You have, and then arranging in such a way as dx will come first. So you will have y dx minus 2x dy is 0. So we have, okay, we have derived the original, or rather the differential equation associated with this family of curves. Okay, now the next step is we can recognize already that m is y and n is negative 2x. From this relationship, we will have to construct another differential equation, okay, which is n dx minus m dy. So here form the dE and dx minus m dy is 0. Then you will have what? Our n is negative 2x and our m is y. Negative 2x minus y dy is 0. Okay, multiply by negative 1, you have 2x dx plus y dy is 0. Okay, obviously you can already what? You can already integrate both sides here. Now integrating there, integrating gives you what? Gives you x squared plus 1 half y squared equals c, or you have 2x1 multiplied by 2, that's 2x squared plus y squared is another constant. We can call that what? We can call that c prime. C prime, okay, which is of course the same as, okay, which is of course the same as 2c. Okay, so notice that this curve is actually a family of ellipses. Let's divide that by c. That will be x squared over what? Over c plus y squared over what? Over 2c equals 1. You see, this is a family of ellipses, and it means to say that the family of what? This will represent a family of ellipses centered at the origin. So if okay, it means that I can draw some, some ellipse there. Okay, all right, ellipse there. Okay, sketch some ellipse there. It means to say that uh, the family of ellipses center at the origin with this what? Okay, with this form, or of course with this form, is the orthogonal, okay, is the orthogonal trajectories of the family of parabolas, okay, y squared is cx, which happens to be, okay, a family of horizontal parabolas vertices at the origin. Okay, this is the concept of, all right, I have explained the concept of orthogonal trajectory.